Okay, if you looked at the last video, which was basics of naming alkanes, we're going to go on and do some more complex examples here and actually use them to illustrate some of the other rules about naming alkanes. So, if we just use the same prefix, parent, suffix system that we used before, let's start with this molecule here. This one's the simplest, then this one, and then this one is somewhat more involved. So the first thing we want to do is exactly what we did before, and that is find the parent chain. So what's the parent chain here? Well, we just number around all the possibilities until we find the longest chain, and this happens to be 1, 2, 3, 4, 5, 6. Now, do we number from the left or from the right? Well, remember, we said we wanted to number from the side that gives us the lowest number for our substituent, and if we have several substituents here, then we just number from the side that gives us the lowest total substituents, the lowest total for each of the substituents. Usually that means counting from the side where we'll encounter the first substituent first. So what this means is 1, 2, 3, 4, 5, and 6. So the substituents are on carbons 2, 3, and 4. If we had numbered the other way, it would have been 1, 2, 3, 4, and 5, and the 3 substituents would have been on carbons 3, 4, and 5. 3 plus 4 plus 5 is more than 2 plus 3 plus 4, so we go for this way. So we have 3 substituents. I'll just circle these so we can remember them when we come back to this later on. But what's the name of a 6-carbon chain? Well, we've seen this before. It's hexane. Now, what do we do now? Because there is an issue that's coming up now. We have 2 of these substituents that are 1 carbon long each, and we've seen these before. These are methyl groups. And if a 1 carbon substituent is methyl, what's the name of a 2 carbon substituent? Well, I just said it. It's ethyl. So then that brings up the question, which one comes first? Do you put the ethyl first? Do you put the methyl first? Does it depend on the number? The fact is, it doesn't depend on the number at all. It depends on the alphabetical arrangement of the first letter of each substituent. Essentially, the one that is closest to the start of the alphabet is the one that comes first. So therefore, it's going to be ethyl, methyl. But we can't just put ethyl, methyl, hexane because we need to know where everything is. So what carbon is the ethyl group on? Well, it's on carbon 3. So 3, remember we put the number, dash, okay, 3 ethyl. Now the methyl groups are on carbons 2 and 4. So we need another hyphen. You remember we need a comma to separate our numbers, another hyphen here because we're going from a letter to a number. And how many methyl groups do we have? Well, we have 2, so we need that prefix to tell us that we have 2. Now I'm running out of space here, so I'm just going to write dimethyl up at the top here. So, does that make sense to everybody? 3, let me see if I can write this out again all in one line. 3 ethyl, 2, 4 dimethyl. You can see this is a lot of things to be putting in a name. Believe me, it gets much more complex than this. 3 ethyl, 2, 4 dimethyl hexane. Alright, let's move on to this one. Longest carbon chain again. Well, it looks like it's this long one here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Which side do we number from? Well, if you figure it out, it's going to be from the left for the same reason as before. Now I'm numbering these carbons here, and it's actually not bad practice, at least when you're starting out naming these things, to actually do so. And then I also try and make a point of highlighting each of my substituents, because not only when I highlight them do I know where they are, but I can tell that if I just write a circle here, it's usually a methyl group, and if I write something bigger, then there's obviously a bigger group there. So methyl, ethyl, and then we have this odd looking thing, looks like the end of a shark's tail. Do sharks have tails? Anyway, never mind, sorry, that's getting off topic. What is the name of a 9-carbon chain? Well, it's the rather odd sounding nonane. Well, it sounds like a punchline to a joke, but it's nonane. So, substituents, we have a methyl, we have an ethyl, and we have a, well, what's a 3-carbon substituent? Well, 3-carbon substituent is propyl. Okay. So let's say I had this chain and I had 3 carbons coming off it. This would be a propyl substituent. Okay, 1, 2, 3 makes sense. So I can use the same name for this one. Whoa, hang on. That is different to that. Can you guys see that? Can you see what the difference is? This propyl group is attached to the parent chain by its N carbon. This is not. This is an isomer of this. The actual name of this is isopropyl. Iso meaning isomer. So we've got isopropyl, methyl, and ethyl. So which one's going to come first? Well, I for iso, M for methyl, and E for ethyl. So obviously the ethyl comes first. Alright? Now, what carbon is the ethyl on? Well, it's carbon number 5. So 5 ethyl. Let's get another hyphen there. What's that? 4 isopropyl. 4 isopropyl. And I'm running out of bloody room again. Bollocks. Anyway. And then 3 methyl nonane. Okay? Does that make sense to everybody? Alright, now here comes the tricky one. Alright, so let's see what we can do about this. First off, longest carbon chain. Well, it looks like it might be 1, 2, 3, 4, 5, 6, 7, 8. Okay. Oh, hang on. What about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11? Boy, that is a lot longer. So always remember, the longest carbon chain isn't necessarily the one that goes straight left to right. It could go down here. As long as it's a continuous chain of carbons, it's the longest carbon chain. So therefore, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Well, now we have to figure out what on earth is the name for an 11 carbon chain. Well, for 10 carbons it's decane, and anything past 10, you simply stick something on the front of dec to signify how many other carbons are on there. So for 11 carbons it's actually undecane. I think that has roots in Greek or Latin or something. I should know, but I don't. So, undecane. And let's do the same thing we had that we did before. Let's do our substituents. Well, I have this one here, this one here, and this one here. But I also got something coming off carbon 5 that is that a methyl or a propyl or I don't know, but there's this whole thing coming off here. Okay, I'm a little bit worried about that. What do I do? Well, how about I just try and give you a way to name this? Okay. This is what makes, or this is what can make molecules like this potentially more complicated to name when you have a substituent that can't just be named as one group. For example, this can just be named as ethyl. This can just be named as methyl. But what if I have a substituent which has its own substituents coming off it? Because just imagine, if this methyl group wasn't here, this one, you would have a 1, 2, 3 carbon substituent. That would be a propyl. So this methyl group is actually coming off this substituent. So I have a substituent with its own substituent. Okay? It's like the parent chain is the landlord. The propyl group is the tenant. And then maybe the methyl group is the tenant's pet bee or something like that. So, how do we do that? It's actually not that complicated. We already said this is a propyl group, okay? So all we do is we say, okay, this is carbon 5 of the parent chain. This is the first carbon of my substituent. And so what's the longest carbon chain coming off there? Well, it's either 1 carbon or 3 carbons. Remember, I can't go in both directions, and my substituent name has to start, or my substituent length has to start here. So it's 1, 2, 3. That means my substituent is 3 carbons long, so it's propyl. But coming off carbon 1, there is a methyl group. So what we're saying is, we have a propyl there, but there is a methyl group. No, shit. Oh, sorry, I didn't say shit. Oh, well, I said it again. Okay, I did say shit, and I just said it again. Okay, I'll just stop saying it. Propyl, let me just try that again. Propyl. I'm going to try and leave myself enough room to write methyl here. Methyl. We said we have a propyl group with a methyl group coming off on carbon number 1. Now the issue that we have here is that this whole thing is coming off carbon 5 of the parent chain. So anytime we have different numbers in a molecule signifying different things, we have to make sure we find a way to make sure the reader doesn't get confused about what he's looking at. Okay. So if I was to say, well, the location of this whole thing on my parent chain is carbon 5. Obviously, I can't just say that. Okay. So I'm actually going to put a hyphen there, but I'm going to put this whole thing in brackets, because then I can tell that what I have in brackets here is its own unit, which is this guy. That happens to be coming off carbon 5 of the parent chain. Alright. And then if we ask ourselves, well, we have this as one substituent, we have 3 methyls here. Do the 3 methyls come first, or does this come first? Well, let's just do alphabetically again. I have methyl and methyl, but this whole thing is methyl propyl. So we have an M and a P there, so we'll put the 3 methyls first. And if we do that, could you guys say what the location numbers of each of the 3 methyl groups are? If you can, I hope you would say 2, 2, 3. Now let me leave a whole ton of room here. 2, 2, 3. Remember, we need a hyphen between numbers and letters. The prefix for 2 of something was die, so what's the prefix for 3 of something? It's try. Okay, 223, trimethyl. Again, we need a hyphen between our letter and our number, which in this case is going to be the 5. Okay. And then I just write everything out here again. 1-methyl, propyl, and decene. Now, you'll also see that there are other ways of naming these groups, and you'll see this in the book. You'll see this sort of group can also be called sec-butyl. It's 4-carbon chain with the connectivity to the parent chain at the second carbon. But I'll let you decide about which one you want to use. I'm perfectly fine with this because here there's no ambiguity at all, but it's really up to you. And my cat is about to crawl all over the computer. In fact, she just did, so I think that's a good time to stop.